Imagine pouring yourself a cold glass of milk at breakfast. It looks pure, smooth, and fresh, but few of us ever stop to think about how that carton made its way to the supermarket in such perfect condition. The truth is, raw milk straight from a cow doesn't stay safe for long. Left at room temperature, it quickly becomes a breeding ground for harmful bacteria. So how does milk transform from something unstable into a product that can sit in your fridge for weeks, safe to drink and consistently fresh? The answer lies in a fascinating journey that takes place behind factory doors, inside a system of sealed steps most people never see. This story isn't just about milk, it's about science, technology, and the history of a drink that has nourished civilizations for thousands of years. Milk has been part of human life since ancient times. From Egypt to Greece, people consumed it as food, medicine, and even a symbol of vitality. But for centuries, milk was a risky choice. Without refrigeration or sterilization, it spoiled quickly and couldn't travel far. Families consumed it almost immediately after milking, because within hours it could turn sour and unsafe. It wasn't until the 19th century that everything changed. A French scientist named Louis Pasteur introduced heat treatment, what we now call pasteurization. This simple yet revolutionary process turned milk from a fragile, risky liquid into a reliable, safe, and widely consumed staple. By the early 20th century, the United States had built an entire dairy industry around this breakthrough. School lunches, breakfast tables, and household refrigerators were never the same. Milk became more than a drink. It was marketed as an essential source of nourishment, especially for growing children. Today, modern dairies look nothing like the old image of a farmer with a stool and a metal pail. Instead, cows are led into clean, climate-controlled stalls, where automatic milking machines do the work. These stainless steel suction devices use a gentle vacuum rhythm that mimics the natural nursing process. The system is efficient, humane, and surprisingly fast. A single automated setup can milk nearly 200 cows in an hour, something no human could ever achieve by hand. The milk flows directly from the cow through sanitized pipes into sealed storage tanks. At no point does it touch the open air, which dramatically reduces the risk of contamination. This is where modern food safety begins, by making sure the product is protected from the very first moment it leaves the animal. From here, time and temperature become absolutely critical. Fresh milk is chilled to around 39 degrees Fahrenheit 4 degrees Celsius within minutes of leaving the udder. This rapid cooling is what keeps bacteria from multiplying. Specialized transport trucks, equipped with insulated tanks, arrive to collect the milk. These trucks are like giant rolling refrigerators, ensuring the liquid remains cold and stable on its way to the factory. By the time it arrives at the plant, the milk is still as fresh as it was at the farm, but it's about to undergo a series of carefully controlled transformations. The first step inside the processing plant is cleaning. Even with the most advanced equipment, tiny bits of dust, hair, or hay can still find their way into the milk. To remove them, the liquid passes through ultrafine mesh filters. These filters are swapped out constantly to keep hygiene at its highest standard. Once filtered, technicians test the milk's natural fat content. Not all milk is the same. Some cows produce milk with more cream, others with less. To make sure every carton on the supermarket shelf tastes identical, the industry uses a process called standardization. This means the fat is adjusted, either by skimming off excess cream or blending some back in, depending on whether the final product will be whole, low-fat, or skim milk. Large balancing tanks, some holding up to 50,000 liters, mix everything together, ensuring consistency across massive batches. By the time this step is complete, the milk is clean, uniform, and ready for the most important stage of all. Pasteurization is the moment when milk goes from risky to safe. The liquid is pumped into plate heat exchangers, complex machines that use thin metal plates to pass milk on one side and hot water on the other. The two never mix, but heat transfers instantly. The most common method, called HTST high temperature, short time, warms milk to about 161 degrees Fahrenheit 72 degrees Celsius for just 15 seconds, then cools it back down almost immediately. That tiny window of heat is enough to kill dangerous bacteria like Salmonella, E. coli, and Listeria without damaging the taste or nutritional value. The margin for error is razor thin. If the milk is heated even a few seconds too short, or if the temperature drops by just a couple of degrees, harmful microbes could survive. In that case, entire tanks of milk, worth thousands of dollars, would need to be discarded. It's a high-stakes process that ensures safety with scientific precision. Even after pasteurization, milk has one more challenge. It naturally separates over time. The cream rises to the top, forming a thick layer. That might sound old-fashioned and natural, but most consumers expect their milk to look uniform and smooth. Enter homogenization, a process that has become just as essential as pasteurization. During homogenization, milk is forced through tiny nozzles at pressures exceeding 2,000 pounds per square inch. The extreme force shatters the fat globules into microscopic droplets that remain evenly dispersed throughout the liquid. This not only prevents a cream line from forming but also improves the milk's stability and shelf life. What you get is the consistently smooth, creamy liquid Americans have come to know and love. Once pasteurized and homogenized, milk is finally ready for packaging. This is where the industrial scale of production becomes most visible. Sterile filling lines crank out thousands of cartons or bottles every hour. Machines fold cardboard, insert plastic spouts, and pump in exactly 1 liter of milk at a time with astonishing accuracy. Each package is stamped with a lot number and expiration date so it can be traced back to its source. Some factories use plastic bottles instead, blowing and shaping them on site before filling. Whether it's a carton or bottle, packaging is designed with one purpose: to protect the milk from light and air, both of which can degrade its freshness and flavor. Once sealed, the packages are quickly moved into refrigerated storage set between 35 and 39 degrees Fahrenheit. Conveyor belts whisk them to waiting refrigerated trucks, which then fan out across the country. Incredibly, within just 48 hours of leaving the cow, that same milk can be sitting in a supermarket cooler, ready to be poured into your glass at home. And of course, milk is only part of the story. It rarely comes alone at the breakfast table. According to Statista, Americans buy nearly 3 billion boxes of breakfast cereal every year. For many families, cereal isn't just food, it's nostalgia. It's the sound of flakes hitting a bowl on a Saturday morning while cartoons play in the background. But beyond the colorful mascots and promises of whole grain goodness, how are those crunchy, sweet, and sometimes sugary shapes actually made? Is cereal truly packed with nutrients, or is it mostly clever marketing wrapped in a brightly colored box? To understand cereal's place in American life, we need to look back at its history and its journey from raw grains to the products lining store shelves. Cereal as we know it was born in Michigan at the end of the 19th century. Dr. John Harvey Kellogg, a physician at a sanitarium, invented toasted flakes as a bland but healthy food for his patients. What started as a medical diet quickly spread beyond the walls of the hospital. By the early 1900s, Kellogg's Corn Flakes were showing up on breakfast tables across America. It didn't take long for competitors like General Mills, Post, and Quaker to enter the market, each introducing new flavors, shapes, and mascots to capture attention. By the 1980s, cereal was more than food, it was a cultural phenomenon. Advertising campaigns targeted directly at children turned cereal boxes into miniature billboards. The characters on those boxes became household names, and the ritual of eating cereal in the morning became deeply tied to American childhood. Inside the factory, cereal production begins with raw grains like corn, oats, wheat, or rice. These arrive in massive bulk trucks carrying up to 30 tons at a time. Once unloaded into silos, the grains go through a cleaning process where air suction systems remove dust, stones, and leftover husks from the fields. Metal detectors scan for stray fragments of farm machinery. Only clean, uniform kernels move forward. From here, the grains are graded and sorted for size and quality using large rotating drums. Consistency is key, without it, the final product would be unpredictable. Once ready, the grains are transferred into giant pressure cookers. These massive vessels hold thousands of liters, where steam and water raise the temperature to around 300 degrees Fahrenheit 150 degrees Celsius. The heat softens the starches and begins to break down the grain's natural structure, preparing it for the transformations that give cereal its iconic crunch. Imagine walking into your kitchen on a busy weekday morning. You grab a bowl, pour in a handful of crunchy cereal, splash on some cold milk, and take that first satisfying bite. Or maybe you unwrap a bright yellow slice of Kraft cheese to melt over a sizzling burger patty. These little moments feel so ordinary that we rarely stop to think about them. But behind that crunch of cereal and the melt of cheese lies an entire world of machines, science, and history. Every box and every slice is the result of carefully engineered processes designed to make our food last longer, taste better, and fit seamlessly into our daily routines. Today we're pulling back the curtain and stepping inside the factories where two American food icons are born, breakfast cereal and Kraft cheese, and trust me, once you know what happens behind those walls, you'll never look at your breakfast the same way again. At the heart of cereal production, it all begins with simple grains. Corn, rice, or wheat kernels arrive at the factory, but they're far from ready to become the colorful flakes, loops, or puffs you know. The transformation starts when additional ingredients like sugar, malt syrup, salt, and sometimes cocoa or honey are blended in. Factories also add vitamins and minerals, ensuring that the cereal doesn't just taste good but also meets the nutritional standards printed proudly on the box. This first step is where plain grains are infused with the building blocks of the flavors and textures we associate with breakfast. Cooking comes next, and this stage is where the magic really begins. In less than an hour, the dry kernels are transformed into a moist, malleable mass. Think of it like dough, soft, pliable, and ready to be shaped into something new. This cooked mixture serves as the base for every flake, puff, or loop you'll ever pour into a bowl. It's the blank canvas, waiting to be sculpted into familiar forms that make cereal both fun and addictive. The real artistry shows up in the shaping stage. Here, the cooked cereal mass is sent into giant machines known as extruders. These mechanical beasts push the dough through narrow openings under intense pressure. As soon as the hot dough meets the cooler air outside, it expands instantly, puffing up into airy textures. It's the same science you see when popcorn kernels explode, only here it's carefully controlled to produce precise shapes. The result? Crunchy flakes, airy puffs, soft loops, or even filled bites. Think about it, when you grab a spoonful of Fruit Loops, Cheerios, or Rice Krispies, every piece is the outcome of this incredible moment where dough meets air and becomes something entirely new. But fresh from the extruder, these cereal shapes are still too moist. That's where the dryers come in. The pieces travel into long tunnel dryers where hot air, circulating at a blistering 200 degrees Celsius, blows through rotating drums. This process reduces the water content to less than 5%. Why does that matter? Without it, your cereal would turn soggy within hours. With it, you get the crispness and shelf stability that keeps your morning bowl crunchy for weeks, even months. Some cereals take things further by heading into ovens where they're toasted, giving them that signature golden crunch and deep flavor. It's why corn flakes snap just right under your teeth and why toasted O's have that satisfying bite. Flavor and crunch might be set, but the final wow factor comes in the coating stage. Rotating drums spray fine layers of sugar syrup, chocolate, or honey across the cereal pieces, and then cooling fans harden the glaze. This is where Frosted Flakes get their shimmering sweetness and why Cocoa Puffs explode with chocolatey flavor. Without this step, your cereal would go stale in days. With it, the glaze seals in crispness, ensuring that box you buy today will taste just as good a month from now. From here, the cereal moves along endless conveyor belts toward packaging. Automatic weighing machines measure precise portions, usually around 300 grams, before dropping them into waxed paper or foil-lined bags. These bags are sealed tight and slipped into those bright cardboard boxes that line grocery store aisles. This double layer of packaging is critical. It locks out moisture and air, preserving that crunch you expect when you open the box. High-speed lines can fill and close up to 15,000 boxes every hour, each stamped with batch codes and best-before dates for quality tracking. Finally, the boxes are stacked on pallets, stored in climate-controlled warehouses, and shipped to supermarkets across the country. Weeks later, that very box could be sitting in your pantry just as crisp as the day it left the factory floor. Now let's switch gears and talk about another American classic, Kraft cheese slices. You've probably had one melted over a burger at a summer cookout, stacked on a deli sandwich, or stirred into mac and cheese. Americans eat billions of Kraft slices every year, but there's always been a debate. Is it really cheese or is it something else entirely? Unlike traditional cheese, which molds quickly and crumbles as it ages, Kraft slices remain smooth, flexible, and meltable for months. That paradox has sparked controversy for decades. How can a dairy product that should spoil in weeks resist time on a supermarket shelf? The answer lies in a fascinating blend of tradition, science, and industrial engineering. The story goes back to 1914 when James L. Kraft patented a process that changed the way the world thought about cheese. By blending natural cheese with controlled heating, he created processed cheese, a product that resisted spoilage and could travel long distances without refrigeration. During World War I, Kraft's cheese was sent to soldiers overseas, providing a reliable, durable ration that didn't crumble or rot. By the 1920s, tins of Kraft cheese were being distributed across the United States and beyond, and in the decades that followed, Kraft slices became staples in American households. They were affordable, convenient, and designed for modern life. Fast forward to today and the process has evolved into a highly efficient system. Production begins with two sources, fresh milk and large blocks of natural cheese such as cheddar or Colby. These arrive in refrigerated trucks and are unloaded into chilled silos. Technicians immediately analyze fat and moisture content to make sure each batch will deliver the exact same melt and stretch consumers expect. Natural cheese is shredded into small pieces, which makes blending easier and faster. This mixture of raw and aged elements forms the base of Kraft cheese, part traditional, part engineered. From there, the blend enters giant steam-jacketed kettles. Heat raises the temperature to around 80 to 90 degrees Celsius while massive paddles stir continuously. At this stage, emulsifying salts are added, and they're the real secret. These salts bind water and fat together, preventing the cheese from separating into oily messes. Without them, Kraft slices wouldn't have their signature smoothness. The mixture transforms from a lumpy blend into a glossy, homogeneous paste that looks less like farmstead cheese and more like a silky liquid waiting to be shaped. Next, the hot paste flows onto cooled steel belts that flatten it into thin sheets. The belts move at carefully controlled speeds, ensuring every slab has the same uniform thickness. This step defines what makes Kraft slices so recognizable: not crumbly, not rigid, but bendable, smooth, and consistent. Once the sheet reaches the right firmness, sharp rotary blades divide it into perfectly sized rectangles. Precision here is everything. Even fractions of a millimeter matter in creating that uniform slice. The slices then travel through cooling tunnels where chilled air locks in their structure, preventing sticking and ensuring they peel cleanly later. Each slice is individually wrapped in thin plastic film by machines that fold and seal the packaging in a single motion. This is what makes it so easy to grab a slice for a burger or sandwich without the dreaded clump of cheese sticking together. Wrapped slices are stacked into packs of 12, 16, or 24, depending on demand, and vacuum sealing removes any extra air to keep them fresh for weeks. Within days, what started as raw milk and shredded cheddar is transformed into a bright yellow pack of slices ready to melt across hamburgers, grilled cheese sandwiches, or nachos in households across America. When you zoom out, both cereal and Kraft cheese reveal the same bigger story. On the surface, these foods seem simple: a bowl of cereal, a slice of cheese. But in reality, they're the results of carefully designed systems that merge tradition with technology. Shelf life, texture, and flavor aren't just happy accidents. They're products of precision. The crunch of a cereal flake, the melt of a cheese slice, every detail has been engineered to fit seamlessly into modern life. And yet, there's more than just science here. These foods are cultural touchstones. Cereal isn't just breakfast, it's Saturday morning cartoons, childhood memories of picking prizes out of the box, and the sound of clinking spoons at the kitchen table. Kraft slices aren't just cheese, they're cookouts, school lunches, late-night grilled cheese sandwiches, and comfort food shared with family. Behind every product is not only an industrial story but also a human one, rooted in nostalgia and everyday life. So the next time you pour a bowl of cereal or unwrap a slice of cheese, take a second to think about the journey that brought it there. From giant machines puffing dough into loops to precision slicers cutting cheese sheets into neat rectangles, your everyday foods carry stories of innovation, history, and culture. They may seem ordinary, but they're anything but simple. And if you've enjoyed this journey inside the factories that shape our meals, stick with us. We'll be diving into even more fascinating stories about the foods we love.